Riddle me this, motherlecker.
Alice and Bob can complete a job in 2 hours. Alice and Charlie can complete the same job in 3 hours. Bob and Charlie can complete the same job in 4 hours. How long will the job take if Alice, Bob, and Charlie work together? Assume each person works at a constant rate whether working alone or working with others. This problem has been asked to students in US colleges. To the professor's surprise, many of the students set up the wrong equations and could not solve this problem. Can you figure it out? Give this problem a try, and when you're ready keep watching the video for the solution. Before I get to the solution, let me go over a common mistake in how students get to the wrong answer. They read the first sentence, that Alice and Bob can complete a job in 2 hours, and translate the names and the numbers into an equation. They say this must mean that AB equals 2. They look at the second sentence, that Alice and Charlie can complete the job in 3 hours, and they similarly convert it to AC equals 3. The third condition, that Bob and Charlie can complete the job in 4 hours, gets converted to the equation BC equals 4. The question of how long it will take for all three of them working together gets translated into the question of what is ABC equals. So to solve this system of equations, they want to solve for ABC, so they can add up all the equations together. We end up getting 2 terms of A, 2 terms of B, and 2 terms of C, to equal 2, 3, 4. If we group the factors, summings, we get 2A, 2B, 2C equals 9. We then divide by 2 and that gets us to ABC equals 9 halves equals 4.5, 4 and a half. So evidently this will be the answer that many students get. They would say that it takes 4.5 hours for all three of them, when working together. But let's think about, does this answer make any sense? We know that Alice and Bob take 2 hours, Alice and Charlie take 3 hours, and Bob and Charlie take 4 hours, but somehow when all three are working together they take 4.5 hours. This makes no sense. When 3 people work together it should take less time than when only 2 people work together. But 4.5 hours is more time, so this answer must be wrong. Not only were the equations set up incorrectly, but any student who submits this answer is not thinking about whether the answer makes any logical sense. So how do we solve this problem? We need to set up the equations in the correct method. We know that Alice and Bob can complete a job in 2 hours, so how do we translate this into an equation? Well, if they complete the job in 2 hours, that means the percentage of a job that Alice does in 2 hours plus the percentage of a job that Bob does in 2 hours equals 100%, or that equals 1. Now since they work at a constant rate, we can say the amount of the job that Alice does in 2 hours is 2 times the amount of a job that she does in 1 hour. And the same thing goes for Bob. So we now have a natural choice for our variables. We can say the percentage of a job that Alice does in 1 hour will be the variable A, and the percentage of a job that Bob does in 1 hour will be the variable B. This leads to the equation that 2A to B equals 1. And that's how we can translate this. We can group this out to be 2 times 2x, the quantity AB equals 1. So we can now translate the second sentence. We have Alice and Charlie completing the job in 3 hours. This will translate into 3 times the quantity AC equals 1. Where C is the percentage of a job that Charlie completes in 1 hour. We also have that Bob and Charlie can complete the job in 4 hours. So that would mean 4 times the quantity BC equals 1. Now we want to figure out what would happen if they all three work together. So we are needing to solve for the time t, x, a BC, equals 1. We need to solve for this variable t. So how do we do that? Well, we can similarly add up all the equations. But we have different quantities of each of these variables, so in order to get the same number of each variable, we're going to do a little trick. We're going to multiply each equation so that there's a leading coefficient of 12, which is the lowest common multiple of 2, 3 and 4, so the first equation will multiply by 6. This will get 12 times the quantity AB to be equal to 6. The second equation will multiply by 4 and the third equation will multiply by 3. We can now add up all of these equations. We'll end up with 12a, 2 times, 12b, 2 times, and 12c, 2 times, and this will be equal to 643. We can factor out the 24 of each of these variables, and that will be equal to 643, which equals 13. We now divide by 13 and we end up with 24 divided by 13 times the quantity ABC equals 1, and that is what we wanted to figure out. So we go back to our setup and we can see that we get to the answer of 24 over 13. So the job will take 24 over 13 hours, or about 1 hour and 51 minutes. And this is a sensible answer because it takes less time than any pair working together. Did you figure this out?
Riddle me this, mother lecker.